the ledger is immutable. You don't
Mm.
have to validate it yourself. It doesn't even probably have to be validated in real time. It can be validated by some other authority, and there can be a plethora of types of authorities who are participating in it. There could be even NGOs who are participating in it, and they could do this even at a slightly staggered manner. It doesn't really have to be a system which operates perfectly for every single scenario or a case.
Yeah.
It just has to be a good enough solution that works at scale, and that's all it has to be.
I live unbanked off of cryptocurrency, and I use Bitrefill extensively because it lets me pay with crypto at places that don't yet accept it directly. This one service, more than any other, helps me live on crypto, pay your prepaid phone bill, or buy gift cards to thousands of major retailers around the world, all with cryptocurrency, including for exact amounts so you don't have to buy more gift credit than you need for a specific purchase. You can use Bitrefill without an account, but if you get an account, you can earn rewards points, which translate to savings, and you can also hold a balance denominated in dollars or euros to protect yourself against market crashes. Go to bitrefill.com, click Create Account, and enter the referral code DCN, or follow the link in the description. Hey everybody, I have the wonderful pleasure of speaking with the one and only Nithin Mani today. How's it going, man?
It's going good. Thank you for having me here. A pleasure to meet you and be on this discussion.
Yeah, so really quick, do you want to describe what it is you do, what your company's about?
Sure. To put it in a single sentence, I would say my company is into developing software infrastructure solutions for Bitcoin SV. We would like to call it just Bitcoin, but for the greater audience,
Yeah.
I'm just explaining it as Bitcoin XV.
Yeah, so what kind of infrastructure in this
Right.
example?
So yes, so we work on multiple layers. In the terminology that I am used to, layer zero, that is
Mm-hmm.
sort of the P2P overlay network upon which the Bitcoin consensus protocol operates,
Mm-hmm.
and then the Bitcoin consensus layer itself. We are working on a high scaling, distributed node for the Bitcoin SV ledger, and also layer two application protocols for things like self-sovereign identity and various other related things that can be incorporated on top. So we are pretty much a full stack company which works on products and solutions all through. But it might be a little obscure for people hearing about us for the
Mm-hmm.
first time. We you know came into the public view early this year. Until then, for quite some time, we were in stealth mode. And during one of the developer meets, a popular meet called the Cambrian event that happens in the Bitcoin SV ecosystem, that's when we came out public and launched our first product, which is called the Xoken Nexa, which is a index and serve solution for a highly scalable, future, need for the Bitcoin SV blockchain.
Yeah, so the reason why I wanted to talk to you to begin with was regarding the
Mhm.
subject of scaling in general. And
Sure.
to sort of recap for the audience what the scaling debates in cryptocurrency, which of course started with BTC, with Bitcoin. Um,
Right.
I don't remember what year exactly the discussion started because I remember they got much more heated in late 2016. It might have been as early as 2014 or before, but at some
Hmm.
point people started to. Uh, there was an artificial 1 megabyte block size limit that was placed on Bitcoin, and
Hmm.
I believe by Satoshi himself. But it was, I wasn't around in the days. I don't remember, very clearly, but it was supposed to be I guess a temporary limit, and it was became a permanent limit to where it sits to this day on that chain. And
Right.
basically during that time there was a lot of discussion of, well, how can we scale things, how can we make, how can we take more transactions, should we, what are the problems with it, all this kind of discussion. And slowly but surely the block started to fill up with transactions because Bitcoin was becoming very popular, and then
Absolutely.
over at some point it started to become really not acceptable just how congested the network was. And that's what I stopped using Bitcoin was in 2016. In late 2015, I stopped accepting fiat currency and decided to live entirely off of cryptocurrency for a great experiment, and it was going great. But by the end of the next year, by the end of 2016, I couldn't do that anymore. It was untenable. It took hours to get confirmations, and this was before the peak congestion times. And then at some point, basically all the people interested in scaling the blockchain on-chain ended up leaving, most around a fork called Bitcoin Cash. And then, of course, now there's Bitcoin SV. There's a whole bunch of other projects. But after that point, in the public consensus, the public kind of discussion, it basically said, it became, and I started to see even articles not from crypto dedicated services, that they started to say things like blockchain is inherently cannot scale. It has scaling problems. It does not scale. It cannot process. I started to hear this stuff, and it's kind of like, well, Bitcoin never tried to scale, really. It just stopped at 1 megabyte and then didn't increase. And it was just sort of assumed that you can't go past that because bad things will happen. And the more I learned that that's absolutely not the case. But it's become this kind of discussion that, you cannot scale on chain. Just it's really inefficient. It's not going to work. You're going to have all kinds of problems. And then there's, of course, a few people that just say you can scale effectively, infinitely on chain. Oh, just make the blocks bigger. And those, I'm trying to, of course, reconcile those 2 points together and just sort of get a greater picture on scaling, because I think a lot of people don't understand how blockchains can scale, what problems they run into, and what little nuances and trade-offs you have to run into to make things scale. So first, from your perspective, is there any what are the limitations, the upper limitations to scaling a network on chain? Like, how many transactions per day do you think you could process on the Bitcoin chain? Maybe not today, but like theoretically, if you implemented some optimizations or whatever down the road.
So at this point, I think quoting a number does not make a lot of sense, but it's very easy to see, theoretically at least, why there is no limit from any of the underlying, say, wrongly quoted laws of physics and things like that. There is no such thing, and we have ample, headroom for us to continue scaling forever until our needs are continually kept met, right? So we can continue to scale as long as we have the need for it. There is no reason to scale to billions of transactions per second today, but it's a continual process. It's not a definitive step that has to happen where it suddenly flips to an unlimited limit or something. It's not as trivial as removing that 1 megabyte the limit in the code. There have to be so many other things that have to come together in terms of the algorithms that make up the software and the software infrastructure, in terms of the network topology and the hardware and various elements that have to go together. So there is absolutely no concern at all. In fact, if we have to look at any analogy of how the internet works today, just like the internet protocol upon which pretty much the whole of internet works today, there is no real scaling limit. It just continues to have ample scope for supporting every demand that we place on it.
Yeah, so when we talk about on-chain scaling, and we talk about scaling limits. So first off, in your view, which obviously facts can change down the road, and the opinion surrounding the new reality could change, but what size transaction roughly would make sense? We're talking purely, say, financial for now, but what size transaction makes sense for the smallest what you'd want to put on chain? So for example, obviously, let's say you're buying the coffee, right? That's $2 or something like that. That makes sense on chain. But what about sending like a 5-cent micropayment? Does that make sense on chain? What about a sub-cent?
Absolutely.
So is there?
Absolutely.
what is the smallest that makes sense to send in just a regular on-chain transaction?
You could send just one Satoshi if you will, because if a miner is ready to accept that, you could just send one Satoshi. It's end of the day, we don't even distinguish a micropayment versus a large payment, right? So the protocol is a protocol. It's just agnostic to the whole thing in a way. It's not entirely true, but we like to view it in that manner. This whole, I mean, you rightly put it when you started the discussion that it's an artificially placed limit to have a 1 megabyte cap. It's not like we are trying to hack the system by raising the limit. We have to understand that when there is a reference implementation that's being released to the wider public, there are certain restrictions that are put in place so that it operates in the practical, the scenarios of various other attack vectors and DDoS attacks and things like that. It's nowhere mentioned in any white paper or anything like that it has to be 1 megabyte. And even if it was mentioned, it's something that anybody can critique and question. Why does it have to be 1 megabyte? Maybe it made sense in 2009. Maybe the whole the ecosystem of bandwidth, accessible bandwidth that people have changed exponentially, is what I would say, in many of the developing nations at least, and that had to go away at some point in time. And so any other scaling solution seems pretty contrived to me. The most elegant and the natural way to scale it would be by including more transactions in a block. Well, we hit a problem with this, with the underlying assumptions that people have, especially people who subscribe to the Bitcoin core philosophy. That is, every user of the Bitcoin core network would have to validate the whole chain, like run a full node.
Yeah.
And that seems like, it's an idealist philosophy, but it's misguided. It doesn't serve any purpose at all, because what good is just reading a blockchain and validating for yourself going to do for the system of miners out there who are the only ones that are going to be writing these blocks? Yeah, you can detect something that's amiss, great, but then you don't have to do everything by yourself. You just have to rely on the blockchain and the wider system of players and the system of law and everything else that is there. You can't make this a closed system and make it sound like it's unconfiscatable, and that's like an anarchist philosophy, and that's very easy to see. You don't even have to be a lawyer to see that. We operate in the real world where all these support systems exist. We are not like in the Matrix or something where we are completely in the system. This is a virtual system that we are trying to interact with from our real world, right? So to put it in another way, we have to think a little philosophical. Like, I'm a very technical guy, but I like to validate my technical basis with a fair amount of basic reasoning and thinking through first principles.
Of course.
If we just wonder what is Bitcoin after all, well, before we dive into the made up things like digital gold and stuff like that, from a purely technical perspective, if we look at what does it help us to do, I think two big answers pop up. The first one would be, well, it helps with the double spending problem, right? So there wasn't a very effective solution until Bitcoin came along, and that's a huge breakthrough. And the second one, you could say, some people are passionate about this. They say it's like a timestamping machine, right? So it's a timestamp server or something. Effectively, if Bitcoin scales to unlimited levels, you could say it would be the only clock that we would have to come depend on. But let's keep the timestamping aspects of it aside and look at the double spending problem itself.
Yeah.
So if all it does is say double spend prevention, it has the incentives and the whatever economic, game theoretical aspects baked into it so that it prevents the double spending. That's not by itself, uh, you know, going to solve everything. In fact, why do we? I would say Bitcoin is a tool for us to scale commerce in a way, right? What I'm trying to corroborate here is to show that why we have to still operate within the realms of law, right? So it can't be like you accidentally got a huge credit into your account and now you own that.
Yeah,
Nowhere in the world would it be accepted in the banking system, at least. And the same would apply to this, and the same would apply conversely. If you lost a huge chunk of money, you can't say it belongs to somebody else's keys now. And that's a failed approach to think.
Yeah, it's
So
definitely, that kind of reminds me of, on the other side of things, you have, say, the Monero approach, where the people in the Monero community tend to be very much that way of,
Right.
if not your keys, not your crypto, no one needs to be able to see this. If the regulators have problems with it, that's the regulators' fault, not the actual network's fault. And that's kind of it. It's definitely, I'm not sure, I could call it, let's say, utopian or whatever you call it. It's not something that works today, where people largely accept that there's systems out there, whether it's government, whether it's some sort of private entity that oversees some financial transactions. People want everything to work in a I guess publicly regulated world to a certain extent. And so yeah, like, one thing won't work in that, and you need something that does, as long as you're hoping to work in the present world and not just work in a hypothetical different world.
Absolutely. So anyway, going back to that, what I mean to say is, how does Bitcoin help scale commerce? It's very simple. Like, I had this opportunity to meet Craig Wright for a brief session, and I happened to start off the discussion by making a sarcastic comment. I just asked him, like, for a guy who talks so much about law, why did you bother inventing Bitcoin? At least from his perspective, right? So the outside world may not acknowledge it yet, but so he started answering it, but it was just a joke. In a sense, if you look at it, without Bitcoin, we could perfectly operate. Like, for instance, I could digitally sign something and give it to you, and if I happen to give the same thing to somebody else, you could approach, whatever the legal system there is to, bring me into the purview of a crime that I have committed, right? But it doesn't scale. We would have a long queue of millions of people, standing in front of their lawyers and whatnot. So what Bitcoin helps us to do is try to mitigate that problem and bring it to only exceptional cases. Like, we use credit cards every day.
Yeah.
Of course, there is credit card fraud, but that's a negligible amount that the larger ecosystem of honest players are able to participate in it for greater efficiency. And that's kind of how we should be looking at Bitcoin too. And if we acknowledge this simple fact, now we can throw away those baseless assumptions about everybody has to validate their blocks themselves. And now we can actually, take some solace in the fact that the ledger is immutable. You don't have to validate it yourself. It doesn't even probably have to be validated in real time. It can be validated by some other authority, and there can be a plethora of types of authorities who are participating in it. There could be even NGOs who are participating in it, and they could do this even at a slightly staggered manner. It doesn't really have to be a system which operates perfectly for every single scenario or a case.
Yeah.
It just has to be a good enough solution that works at scale, and that's all it has to be.
Yeah.
So,
and that's my a theory that I have, which I'm willing to drop if it doesn't turn out that way. But my theory, in all these different people who disagree on how much cryptocurrencies can scale, I don't think that my guess is that I don't think people will have that differing views on the actual technical limitations. I think that most of these discussions, when people talk about technical limitations, are actually speaking of philosophical limitations. And
Yes,
so,
absolutely.
for example, when you're saying about, oh, it can't scale 1 megabyte blocks only, and some people saying we should make them smaller and all this, uh, you have the priority of everyone should run their own node and validate all their own transactions and everything. But then the other side, you say, well, you can go to gigablocks and beyond, and as long as it is being verified, validated, audited by someone, and I have access to that party, I don't necessarily care if I do it on my own little computer here. And so
Yes.
then it's that little sliding scale of like how much infrastructure do you have to participate in yourself. I would say maybe the Bitcoin Core type group of people is like absolute. You have to participate in every little thing. And then now we have the sliding scale to the other side of, well, you probably don't have to participate directly at all if you don't want to. And then as you change the slider, the block size slider goes up this way.
Yes, absolutely. If you want everybody to be doing everything, then by definition, that kind of a system wouldn't scale for any domain, right? So we have to, specialize the system and design the whole model in such a way that there are specialized actors who are incentivized to, come up with solutions that compete and give the most benefit to the greater system. And it in the BSV world, we don't even embrace that there has to be like a single implementation that everybody has to run. In fact, it's entirely within the authority and the purview of the miners. Each miner can have their own implementation, and it doesn't even need to be open sourced or any such thing. It can be their Bitcoin mining node that just adheres to the protocol, and it just works with everything else out there, and that's it. Just like the way everything else works today, we don't have the SMTP giants that we have today, or even any of the telecom giants that work in this model. They all are competing with their own implementations and reducing the costs and improving their efficiencies. And that's the same model that Bitcoin is doing. In fact, this is the most natural approach to scaling it.
Yeah.
There is nothing that's contrived in this approach.
So when we're talking about different implementations, what kinds of practical differences would there be between different implementations? And so obviously with the context of there are certain limitations to how crazy you can get, because otherwise you'd be out of consensus with the main protocol, right? Otherwise you'd hard fork the whole coin. But so like what kinds of differences? So for example, how big a block you might accept would be one that would be a difference, right?
It could be, and that's not necessarily baked into the code. Like it's not a hard coded value, is what I mean. It could be something that the miner decides to accept through trial and error largely, and also by sampling how the current the system is operating. The current blocks are looking. If most blocks are within say 1 gigabyte, and there is a sudden attack that's going to happen that is going to eat up all the mempool space and things like that. To prevent those kind of scenarios, a miner could put some limits in place, but that's just a temporary config value that can be removed and continually keep increasing the limit that they artificially place themselves.
Yeah.
So the other things could be one thing is a consensus protocol, like you said. If something violates the consensus, then obviously it's going to fork away, and one of them is going to stick out like a sore thumb. And the other aspects which are not part of consensus are things like, what is the dust limit, what is the transaction fee for relay and whatnot, and also what is the ancestor chain limit for unconfirmed transactions, right? There could be different implementations which have different values, as long as they are, mining the candidate block. They may have different restrictions in place, But if they're going to be ingesting a block that's from a different miner, some of these limits won't even apply to them because they would be game theoretically expected to take in, and it's just part of the consensus protocol as well. Moreover, there can be numerous changes in terms of the algorithms themselves that make up the mining node for how one wants to leverage. We have a different approach to things, and we are being a much smaller company trying to put out a Bitcoin mining node in a purely enterprise license approach against the existing and also the upcoming Terranode project from OnChain. It's a very different approach here at Bitcoin SV compared to what we witnessed in the recent couple of days with Bitcoin Cash, wherein that's a very, I don't know what to call it, whether it's a communist model or what, trying to subvert a protocol by having a de facto team that's going to be siphoning off some monetary value is not making any sense. It's, after all, a protocol. You just make your own implementation that hopefully adds value to someone, and they're going to pay for it. And if you don't, that's the typical model in which most entrepreneurs work today in every other model. Why shouldn't it be the same way in Bitcoin, isn't it?
Yeah. And so with Bitcoin in, prior to, let's say, 2017, this could have been possible without any significant chain splits, only if there had not been that 1 megabyte limit. Is that kind of the way it worked? So like, because there was a 1 megabyte limit, there was disagreement and the protocol had to split. But if there had not been that limit, then we would be today where, let's just say, the way we are with Bitcoin SV, except without any of these crazy forks.
Well, it's hard to say because the Bitcoin core team didn't introduce SegWit just for the 1 megabyte limit to be able to cram more transactions into it. That seems like like not a very efficient way to do things. I think the whole transaction malleability and the Lightning Network agenda was the precursor to do this whole thing. And that is, again, in my opinion, not the most elegant approach to scaling, but then it's very clear to see it's to actually serve an agenda, whatever the agenda might be. When you have a protocol that does it inherently, and in fact, Bitcoin has this special property, having this UTXO model, where it can scale pretty much infinitely because transactions can be processed in parallel to a very large degree. And the only challenge comes up when you have to topologically sort them. And we have been working on very interesting algorithms to give extremely good throughput with regards to that, many orders of magnitude higher than what we see today in the Bitcoin network. And this is something that any computer science student should be able to validate. This is not something that is subjective, that has to be debated. It is an objective thing where you establish what's the time complexity and whether the algorithm is inherently parallel or not. It does not need any tweaking. It's been this way from the very beginning. And it just didn't have people look at it with the right vision, is what I would say. And I'm very glad that the team with the OnChain and Craig Wright and all of those people forked away, because if it had not, then we would have been stuck with certain other limitations with even things as simple as CTOR, which was completely unnecessary once again. Again, we can only speculate what the agenda was, because the objective answers that have been furnished so far publicly don't hold water.
Yeah. It's a very strange world we live in if you think about that. But
Yes.
when we're talking about scaling and limitations, and obviously when we're talking about scaling massively, one limitation that comes in is the ability for the individual to run their own entire piece of the infrastructure. Where, if you want to scale larger, it becomes difficult for everyone to run their own node, especially on a little Raspberry Pi device. And and of course everyone could possibly run their own node even under huge scaling if they decided to invest just a little more into their infrastructure. But why would you? So there's that one limitation. Now, what about block propagation, where when, say, a node propagates a block, it has to reach all the other nodes in a certain period of time, and then if it doesn't happen, then you get orphans, you get other things like that. And for example, one thing that stuck out in my head from, I think it must have been years ago by now, but of Peter Reason of Bitcoin Unlimited was talking about, he started to test the gigablock, and he said that under these tests, it took about almost 10 minutes to propagate to all test nodes on the network, which was, I think 10 nodes or something, which is very few nodes. And it took almost a whole 10 minutes to propagate this giant block to all these things. And I'm sure things have improved significantly since then with a bunch of optimizations. But do you want to just talk a little bit about what are some limitations of propagation?
Yes, absolutely. So before we go optimizing, tweaking, and making sure we squeeze the last bit of performance out of it, we have to dial back and see what is the problem that in the larger picture, what are we trying to solve? It's a misconception that we have to propagate the block to all the nodes in the network, right? So first we have to clearly understand the Bitcoin network has clear roles. Firstly, there is something called SPV, which has its own greatness to it in terms of SPV makes things so much better, which none of these proof of stake blockchains can have as easily. As you know, the proof of work is very, very trivial to validate by a light client, and we are able to serve a very succinct proof. Anybody could serve it. It doesn't even have to be a full node. In fact, the first product that we launched, the Xoken Nexa, wasn't a full node. It was just going to be serving, proofs and other Bitcoin blockchain data in an efficient manner, and it could do it at scale. Like even if we had blocks with billions of transactions, because of the logarithmic nature of these Merkle trees, and we incorporated a in-house innovation that we came up with called the transpose Merkle tree. So we are aware of how the typical Merkle tree looks like, but as we are constructing the Merkle tree, what we would do is transpose the intermediate nodes in the Merkle tree in such a way that it is highly efficient to even make the tree and also retrieve the Merkle paths or the branches subsequently, because it's just a trivial walk from the leaf node to the Merkle root when you have to retrieve it. And when we are using a native graph database, it works very well at scale. So anyway, coming back to, can you just refresh me? What was the point that you were asking me to?
Yes, about limitations of block propagation.
Yes. So the block propagation. So we have to understand that if there are, say, a protocol of a network of millions of people using Bitcoin in the future, then there is only a very, very small percentage of people who need to have the entire block within their system. Most of them are only interested in confirming that their transactions were included in some or the other block. And that is taken care of by SPV, and it's very trivial to validate stuff. And next thing we have to see is it's not like a mesh network or a P2P overlay network where the likes of Ethereum and Bitcoin Core are trying to have. This is where we have to, I think, give some due credit to Craig, right? Because he's like the only guy who brought up this topic of how the network topology would look like in the practical world. And there has been a lot of talk within the BSV space about the small world network. So basically, we have to look at this in two separate networks, right? So in the core, there is what we have a small world network, or we can call it a mandala network. It's actually a term that originates from the Indian graphic designs, which are optimal in a certain way, wherein there is almost complete connectivity between the nodes which are in the middle, right? And they happen to be the miners, and maybe immediately after there is a ring of service providers, and then there is this outer periphery of millions of nodes. So you could imagine maybe in the inner circle there are like 100 nodes, and so this decentralization is not a goal in itself. It's just a means to the goal of making sure we have a transparent and auditable system that can operate at global scale, right? So when we have all these core miners and all these core operators in the middle, and they are connected to one another, now the propagation can happen a lot faster. And propagation does not have to be a single algorithm as well. In fact, it's up to the miners for how they decide to exchange the blocks. Between, say, miner A and B, they may have a very high-speed fiber optic network, which are co-located or whatnot, and they could choose to do it a different way. And there could be another miner who has maybe the same protocols for block propagation, that a common block propagation protocol, in other words, that does the propagation of the protocol and the validation of the blocks in parallel. That we are working on one such solution, and the name we have given it is called the ultra compression. So basically, the entire block is broken into segments, and these segments are all transmitted in parallel. So the only limits that we end up facing is the round trip time and the latency and things like that. There is no limit per se for bandwidth, right?
Okay.
So imagine if you had like 1 million TCP connections between two clusters of nodes, and they are just sending one transaction each. Then the entire block is propagated within a very small amount of time, as compared to having one TCP connection over, say, a 200 Mbps connectivity, and now you're trying to propagate it. So these people who are in the core of the network have a economic incentive to be there, and they compete to be more and more in the middle of the network, right? So it's just like how society works. You want to be in the middle of business and status and influence and all of those things, and it's very similar. It's completely capitalistic. It's again not a hack or a weird solution. This is in fact how things scale in nature as well. You can't have a solution like the way Bitcoin Core is doing, coming up with satellites and things like that, and expect it to scale. I think it's completely misdirected and doesn't serve any purpose.
Yeah, and so now we're trying to find the picture of scaling. Now, of course, we introduced should everyone run their own node sliding scale, and if you lower that, then you can scale more. And then as far as propagation, that turns into the same thing of, does everything need to be instantly propagated to the entire network? And if you start to slide that down, then scaling also goes far up. And now there's another side of this, which is there's technical solutions to it, but it's not necessarily a technical issue, is economic issues, economic limitations, where the network might be able to process a certain amount of transactions, but for what it costs the actual nodes and miners and things like that to do it, then it might not be worth it for them, because the profit from that might not be high enough to offset their costs. And so, for example, what if it takes a miner about 3 or 5 US cents to process a single transaction in this crazy hypothetical universe I'm describing. But it's only for 1 or 2 cents. They would not, or the fee is only for half as much. Then they probably wouldn't want to process that. But then, if it's the fee is high enough, then it would be willing to work. So what are some of the economic limits, or rather considerations, when you're scaling?
Sure. I think the Bitcoin SV approach is the most, the economic aspects of it favor Bitcoin SV approach to scaling than any other approach. It's very easy to see. The block subsidies are essentially that. They are subsidies when it started, and they're diminishing continually, right? And it's meant to go down because the expectation is we're able to make up for the diminishing block subsidy for the miners with the more transaction fees and that they are able to process. So unless the miners are able to take on and process more transactions, the whole thing is going to fall flat.
Yeah, of course.
Yes, in other words, what I'm saying is Bitcoin Core, unless they make an economic tweak to their consensus protocol, it's very hard to see why it would sustain in the long term. Mm-hmm. But coming back to your question, I think your hypothetical example is a little bit on the extreme. It,
of course,
certainly does not take 3 to 5 cents to process one transaction. But let's agree that there is going to be some limitation wherein there is some cost associated to it. And that's why we have the fees. So miners are not going to be running the Bitcoin node. So what we have, the Bitcoin D that we run today, is I like to view it as a little bit more refined reference implementation. Mm-hmm. It's not something that has all the bells and whistles that a large enterprise, like imagine if Google or Facebook came into being a Bitcoin miner, or ran a mining pool. They would have so many things. They would have AI and machine learning and data warehousing and analytics and so many things going on. And these are the kind of things that would be of interest for future miners as they grow much larger to process larger amount of transactions. Mm-hmm. And they would be able to set the fees. Right now, it's completely ad hoc.
Yeah.
We are probably trying to get more activity, get more users onto the system. So we are trying to keep the dial low so that more users come on. In fact, once our Vega node is released, that should happen in Q1 21, I think the costs are going to be going down drastically in terms of the transaction fees and ancestral limit, dust limit, all of these. And the reason being, there are so many layer 2 protocols out there that can greatly benefit from various applications. So far we have only talked about the financial use cases. Bitcoin being an immutable ledger can open up a wide set of use cases. There is no limit to what you can build on it. In fact, it's just a ledger of what happens. Yes, it's not essentially Ethereum. It lacks certain features, but it's very similar to Ethereum in the sense that it's, if you come from a functional programming world, you would see that Bitcoin script is like a pure function in the sense that it only has access to things that have been passed to it and nothing outside of its scope. Like it does not have global state, which Ethereum tried to do, and we see that they dished the UTXO model, unfortunately, for them, and it's just not going to scale to the level that Bitcoin can do. But Bitcoin is a layered architecture. Now you have events that are immutably put into the ledger, and now various application developers, various business domains, verticals, whatever they are, can build protocols on top of these. We don't want to again reinvent the same enterprises that have a centralized, hold my subscriber base captive kind of a model. Once again, on the Bitcoin system, we have to think about the larger picture here and aim for developing self-sovereign protocols for anything and everything. Give the power back to the user, give greater efficiency, greater choice. The problems that we talk about today about data being the new oil, and we being the product for these large tech companies like Facebook and Google. Hopefully, with Bitcoin, that can be challenged, right? Because now you can have protocols compete against these large corporations. You can have a decentralized Twitter, Uber, Airbnb, pretty much everything that can operate on Bitcoin.
Yeah, and that's we're talking about these economic limits. That also reminds me of that is a good point that very few people kind of see, is that eventually fees have to pay for everything, and even on networks like BTC, which have horrendous fees right now. I haven't checked in the last few weeks, but a few months ago I did check, and it was about maybe 20% of the entire block reward, which is still very, very small. Like, and pretty much every cryptocurrency out there that says, "Oh, we have a fixed supply, everything's good," they're living in fantasy land if they don't realize that everyone's gonna have to pay eventually. And that's one thing that, for example, that Monero does, is it has a tail emission. So they got a bunch of inflation the first couple of years, and then the inflation rate went far down, but at some point it's going to reach a constant permanent inflation limit, because in order to be able to pay miners to process transactions beyond the fee. So basically the idea was people will never pay the amount it'll cost to actually process transactions, because Monero's transactions are much more data intensive, for example. But they will, if you kind of hide the cost from them by making their entire supply become less valuable over time, then that'll kind of work. And a lot of these scaling things, I'm sure, could be solved, if one could call it solved, by just simply having a very high inflation rate and incentivizing people to pay to run their own nodes and all this kind of stuff. You could absolutely do it, but at some point, then your money's worthless. It's not going to hold value over a long period of time.
Right.
So that's the last little thing, is the economic limit of what are you going to actually willing to pay for. And in Bitcoin and other fixed supply currencies, I guess the calculation is that it's paramount to have a fixed limited supply, that's worth paying for. It was worth paying more in fees to use something that has that permanent fixed supply.
Yeah, it doesn't have to be that way. It seems like people are trying hard to come up with a solution to fit their narrative, and they're not trying to look at what's the most obvious thing to do for everyone's benefit, right? And I just keep going back to that. And in the Bitcoin SV ecosystem, as it gathers more momentum, the fees are going to diminish to a great extent, and it's going to be extremely cheap for doing any application that you want to build and use on the ledger. It can't support things like supply chain and EHR data and global enterprise systems if the fees are going to be as high as it is today. So don't go by what fees we are witnessing today. We'll have to look at fees that are hundreds or thousands of times smaller in the near future. Otherwise, people will be incentivized to use their own hyperledgers.
Yeah.
And hyperledgers have their place today just because of this gap where enterprises don't want to pay fees is one big reason. The other could be things like GDPR and where is this data going to live and how does it fit within the context of the traditional legal systems which demand data has to be stored in a geographical location and things like that. That doesn't go well with the public ledger, but eventually that will certainly happen.
Yeah. Well, this has been a very fascinating chat. Where can people find more about your work?
They can certainly visit www.xoken.org. That is
Hmm.
spelled Xoken .org. And we have a bunch of protocols and products and solutions out there. Most of it is open source.
Hmm.
There are some more products that we are going to open source in the near future. And we want to be one of the key companies in this space that provides scaling solutions to support many businesses that want to build and leverage the Bitcoin blockchain.
All right, fantastic. Well, thanks very much for spending your time with me, and I hope you have a great one.
Thank you.